Hi, welcome to this video. In this video, I'll be sharing with you what's tested in DC circuit. Before I go on to our topic, I would like to share with you some of the resources that I've created recently. So one of it is the O-level physics formula. So in this blog article, I go through or I list down all the physics formulas that you need to learn from each topic. Okay, I've also provided a list of physics definitions here. So you'll find all the common definitions that you need to know for your O-level physics exams. And you can find them at this link here. So I provide the link in the description below. I also provide individual links for this blog post on the O-level physics formula and the O-level physics definitions. Okay, so now let's go back to our topic. All right, so let's take a look at the syllabus to see what is tested on the topic of DC circuits. Okay, so in part A, you're supposed to be able to draw circuit diagrams with power sources like batteries, cell, DC supply, or AC supply. Switches, lamps, resistors, which is fixed and variable potential divider or the potential meter, fuses, ammeters, voltmeters, bells, light dependent resistors, thermistors, light emitting diodes. Alright. So basically, for this portion, so if you want to revise this portion, basically just know the symbol for these items. So if you have a cell or a DC supply or a battery, then this is what you'll be drawing. Okay, you'll be drawing this. Okay, and the long one is the positive terminal of the battery or cell, and the shorter line represents the negative terminal. Okay, if it's an AC supply, then you will denote it with this. All right. Next, to draw switch, it will look like this. So this is a switch when it is open. If the switch is closed, it looks like this. For lamp, the symbol looks like this. Okay. For resistor, if I have a fixed resistor, then it will simply be, the symbol is simply just a rectangle. If it's a variable resistor, it will be a rectangle with an arrow. If you have a variable potential divider, it will look something like this. So the ends are connected to by wires. Then here you have an arrow here. So the closer the arrow is to this point, the lower the resistance. The further away the arrow is from this point, the higher the resistance. So basically, for a potential meter, you can slide the jockey along it and to vary the resistance. Okay. For fuse, the symbol would look like this. It's basically a rectangle with a line through it. So the line in it represents the wire in the fuse. So if the fuse melt, this wire will melt. Okay. For ammeters, they are denoted by a circle with an A. Voltmeters, it will be a circle with a V. For bells, they look like this, right? Okay. For light dependent resistors, they look like this. So you have a rectangle with a circle and then two arrows here to like a light. For thermistor, is basically a rectangle here and this. For light emitting diodes, let me draw it here. It looks like this here. Okay, so the arrow points in the direction where it allows the current to flow in. So current will only be able to flow in this direction for a light emitting diode. Alright, next you need to state that current at every point in the series circuit is the same. So basically what you need to know here is current in every point in the series circuit is the same. Okay, then you need to use this concept to solve questions. Okay, then for a series circuit, right, the sum of the potential difference in a series circuit is equals to the potential difference across the whole circuit. Okay, so basically, so if I have if the potential difference across this resistor is 3 volts and the potential difference across this resistor here is 5 volts, then the total potential difference, or if I were to connect a voltmeter here, then what I will see here would be 8 volts. All right, so basically you add up potential difference when they are connected in series. Next, you need to be able to state that the current from the source is the sum of the currents in a separate branch of a parallel circuit. So we have moved on to parallel. So so this is how a parallel circuit looks like. So what this part D is trying to say is to find the total current, okay, you can simply add up the current in the individual circuits, okay, the individual parallel circuits. So for example, if these two resistors, they are connected parallel to each other. So if I want to measure or if I want to find the total current through the circuit, what I'll need to do is so for example, the current through this resistor is 3 ampere, the current through this resistor is 1 ampere. The total current through both resistor, or the total current measured by this ammeter here, will be 4 amperes. Okay, next, in part E, you need to state that the potential difference in a parallel circuit is the same, and so on. So basically what it meant is if I have a parallel circuit, okay, so these two resistors are parallel to each other. So if I know that, for instance, the potential difference here is 3 volts, then the potential difference across this resistor must also be 3 volts. Okay, so PD, or potential difference across the parallel circuits, are the same. Okay, then we learned about R, resistance equals the potential difference V over I. So you need to make use of this formula to solve questions. Okay, then describe the action of a variable potential divider. So basically what it does is it is a variable resistors. So a potential divider looks like this. Okay, so uh, so let's assume this is my um, and I connect this to a lamp. Okay, so this here is usually what we call a jockey. It is movable, so you can move it from here all the way to here. So as you move towards here, the resistance across this lamp will increase. Okay, so basically a potential divider is a variable resistor. So for your syllabus, just look at it as is a variable resistor where you can vary its resistance by moving a contact point, which we call the jockey. Okay, in part H, you are asked to be able to describe the action of thermistor and light-dependent resistors and explain their use as input transducers in potential dividers. So basically, right, what they will give you is they will give you a scenario or a circuit that consists of a thermistor, and they ask you what happens when temperature is high or what happens when temperature is low. Same thing for a light dependent resistors. They'll ask you, oh, when the light intensity is high, what happens? What happens? Okay. So how you answer will depend on how what circuit they give you. Okay, but what you need to know is for thermistors, okay, thermistors looks like this, right? I talked about the symbol just now. So for thermistors, what happens is the resistance increases when the temperature decreases. Okay, in general, that is for a typical thermistor, its resistance increases with decreasing temperature. For a light dependent resistor, okay, so which I call it LDR. So for an LDR, what happens is the resistance increases when the light intensity decreases. So when it is dark, the resistance across the LDR, the light dependent resistors, is higher, and vice versa. Okay, now that you know what happens to the resistance at varying at different temperatures or at different light intensity, you'll be given a circuit problem and asked what happens at high light intensity or at high temperature, and so on. Okay, so that's about it uh, for this chapter. So basically, you realize that a lot of it, or basically what you see, right, will be application questions. So they'll usually give you a circuit and they ask you to find current, potential difference, and resistance. Okay, and the circuit can also contain a thermistors like dependent resistors, variable resistors, and so on. And you need to be able to answer the questions. So it's basically application questions for this chapter. Thank you for watching this video. Do subscribe to keep updated with our latest videos. And if you are interested, we do have an entire playlist on all the topics tested in physics O level, where we share with you what is tested in detail. Okay, in addition, if you want to learn in detail, do check out our courses on Udemy. Bye and see you.